Session 09, Deploying Celery with Docker Compose in Kubernetes. Sessions 01 through 06 assumed a broker and a worker already exist somewhere. This session covers how to actually ship that stack, a full local Docker Compose setup for development, and a Kubernetes deployment for production, including auto-scaling workers by queue depth rather than CPU. A realistic development stack has 5 moving parts. Redis serves as both the broker and the result backend. The Web API accepts requests and in-queues tasks. Worker pods pull tasks from the broker and execute them. Celery beat handles periodic scheduled tasks. And Flower provides real-time monitoring of the entire system. All 5 services share the same Docker file. Configuration comes from environment variables, not the image. 3 key practices keep this Compose stack reliable. First, the health check with condition service healthy stops the web and worker services from starting before Redis actually accepts connections, avoiding the classic worker crash loop on startup. Second, Beat runs as its own single replica service, running more than 1 Beat instance duplicates every scheduled task. Third, configuration comes from environment variables, so the same image runs in both Compose and Kubernetes unchanged. The Kubernetes deployment for Celery workers defines 3 replicas, each running for concurrent task processes. Resource requests and limits prevent one worker from starving others on the node. Both readiness and lightness probes use Celery inspect ping to check whether the worker process is alive and accepting tasks. 3 Kubernetes-specific notes that apply to Celery workers. First, set memory limits close to the worker's real ceiling and combine it with task reject on worker lost equals true so in-flight tasks are rekeyed rather than lost on an OOM kill. Second, Kubernetes sends sigterm then waits termination grace period seconds before sigkill. Set this above your longest task duration or tasks get killed mid-execution on every rolling deploy. Third, do not put a Kubernetes service or load balancer in front of workers, they pull from the broker and receive no inbound traffic. A CPU-based horizontal pod autoscaler is a poor fit for Celery. A worker can sit at low CPU while thousands of tasks queue up, or spike CPU briefly without any backlog. The signal that actually matters is queue length. Kata, the Kubernetes event-driven autoscaler, supports a Redis scaler that reads queue depth directly and scales workers accordingly. This scaled object targets between 2 and 20 replicas, aiming for about 5 pending messages per replica, with a 2-minute cooldown period. A safe rolling deploy without losing in-flight tasks follows 3 steps. Step 1. Ensure task acts late and task reject on worker lost are both set to true so any interrupted task is re-delivered to a surviving worker. Step 2. Use max unavailable 0 and max surge 1 so new workers come up before old ones terminate. Step 3. Set termination grace period seconds above the longest task duration so Celery's warm shutdown has time to finish in-flight work before sigkill. Session 09 Recap. A Docker Compose stack ties together Redis, Web, Worker, Beat, and Flower with health check dependencies and environment variable configuration. Kubernetes worker deployments need memory limits, Celery inspect ping probes, and a termination grace period that exceeds the longest task. Autoscale by queue depth with Kata, not by CPU. Safe rolling deploys combine task acts late, max unavailable 0, and generous termination grace period seconds. Session 10 will cover the final capstone project integrating everything we have learned.